All right, we are back with a couple special cases. The name of this station is No Solution and Infinitely Many Solutions. These are two special cases that will happen when you can't solve an equation. So I'll be honest, most of the time you will solve your equation, you'll use your inverse operations, your distributive property, your combining like terms, and you will get an answer. X equals a number. Most of the time, that is how the process will go. Every once in a while, though, we'll run into some weirdities. So this first example, I'm going to set up my train tracks, and I'm going to start just like I would start any other problem. So in this case, I see parentheses, so I know that my first step is going to need the distributive property. I'm going to distribute this 3. 3 times m would leave me with 3m. 3 times that -7 would give me a -21. So I have 3m minus 21. I'm going to move down the rest of my equation, 35 plus 3m. All right, so I already noticed something, and the thing that I notice is that I have the same number of variables on both sides. I don't have any terms to combine, but I see 3m on both sides. Typically, my next step would be to combine by moving one of my variables to the other side of the equation. So let's say I want to try to subtract this 3m so that it cancels, and I want it to come over here with my other 3m. Now the problem here is 3m minus 3m is still 0. So I'm left with an equation that says -21 equals 35. And I look at that and I say to myself, does -21 equal 35? Are those the same number? Clearly no. Clearly they are not the same number. So what we have run into is a no solution equation. This equation has no solution. There's no number that I can plug in that would make it the same. The way that I can check this is if I go to my y equals slide, I can graph these expressions as linear equations. So 3 times, we're going to use x as the variable, minus 7, there we go. And on the other side, we had 35 plus 3x. If I look at the graph of these two equations, I'm going to very quickly see that these two equations are parallel lines. I see two lines that are never going to cross or intersect. If you think about these as linear equations, they have the same slope, the same number with x, but a different y-intercept. So those are never going to be equal. They're never going to be the same. The nice thing about no solutions is there's no check to do. If there's no answer, there's nothing to check. So the reason that this equation has no solution is because it had the same variable on both sides. We have 3m's and 3m's, but it had different constant terms, a -21 and a +35, which were not equal. So the first thing you could run into is a situation like this, where all of your variables disappear. You end up with two numbers that are not the same on either side, and that means that unfortunately we have no solution. We're going to try another problem. So again, I'm going to start this just like normal. Every problem I want to follow the same process. So I'm going to set up my train tracks. I again see these parentheses here, so I know that I'm going to have to start by using the distributive property. 4 times x would be 4x. 4 times a -3 would be a -12 plus 17. I'm going to move down everything on the left side, so 4x plus 5 is what I'm left with over here. So I've done my distributive property. The next thing I see is that I have some like terms to combine. I have a -12 and a +17, so I could always use my calculator if I needed to. -12 plus 17, that would give me 5. So I have 4x plus 5 equals 4x plus 5. What do you notice about that? Both sides in this case are the exact same expression, 4x plus 5 and 4x plus 5. This means that both sides of this equation are going to be equal no matter what number I plug in. This is a situation that we call having infinitely, it's a long word, many solutions. This means I could plug in any number for x, and I'm always going to get the answer. So let's try it. Let's start by plugging in 0. That's my favorite number to plug in. It's the simplest. So if I plug in 0 on the left, I get an answer of 5. If I plug in 0 on the right, I still get an answer of 5. So 0 worked. Let's pick another number. Let's try, I don't know, 5 this time. So 4 times 5 plus 5. That gives me 25. 4, plug in 5 again for x, and I still get 25. In case I haven't convinced you yet, we'll do one more number. So let's try my favorite number, which is 8. So 4 times 8 plus 5 gives me an answer of 37. 4 times 8 minus 3 plus 17 still gives me an answer of 37. So you could plug in numbers forever and ever, and it will always work. So the reason that this equation has infinitely many solutions is because really it's the same exact expression on one side and the same exact expression on the other side. If I were to type these equations into my y equals, so in this case 4x plus 5 and 4 times x minus 3 plus 17, and if I were to graph these, it looks like there's only one line. That's because these are the same line, just sitting right on top of each other. So no matter where I go on my line, every single point, the lines are equal. Now remember, these are just special cases. These do not happen very often. So most of the time, you will start to solve. You'll use your distributive property, you're combining like terms, your inverse operations, and you'll get an answer. You'll get x equals a number, you'll check it, make sure that it works, and be all set. These cases only happen when you have either the same coefficient in front of your variable, but different non-equal numbers, no solution, or the same coefficient in front of your variable and the same constant also, infinitely many solutions. So use these as good examples. We'll check back after you're done, but these two examples should get you started in case you see a no solution or infinitely many solutions.